In this video, we'll begin creating the Game Manager script and the script that controls the player's actions. Let's start by running the application once to make sure our tile maps are displaying correctly. You can change the background color by selecting the main camera and choosing a color under background type. We can change the color while the application is running to get a good sense of what it will look like, but these changes will be lost when we stop running the application. So after you get a good idea of the color you want, stop the application and then set the color permanently using the same method. You can still see the color change in the main camera preview at the lower right of the scene view, or you can switch over to the game view to see the larger display we had when the application was running. Now, let's create an empty game object where we can attach our Game Manager script. We'll call the object Game Manager and drag it up to the top of the scene hierarchy. I'm also going to reset the position so it sits at the origin of the world. Let's create a new folder called Scripts where we can save all of our scripts. Inside this folder, we'll create a new script called Game Manager. Unity recognizes this particular name and automatically assigns the script a gear icon, but don't worry about this. The script won't actually be treated any differently than any other script, and this icon will go away when we put the script into a unique namespace in a moment. Let's open the new script in our editor, and we can remove these comments that are added automatically by Unity to help clean things up. We are going to control the execution order of our scripts by having the Game Manager determine when they are updated. It is also possible to do this using the script execution order options under the project settings, but for this project, we will handle all of this within the Game Manager. Let's also add the Game Manager script to our Game Manager object in order to attach it to the scene. Now we're going to create another new script called Player. This will be the first script that our Game Manager is set up to manage. In order to attach the Player script to the scene, we will first drag a copy of our Player prefab into our scene. As you can see, the prefab generated a new game object that has all of the components and settings that we defined for our player prefab. But if we add the player script to the object we've just placed into our scene, and then try to change its position, we will get a warning telling us that we cannot modify or delete components on a prefab object. This is letting us know that we should open the player prefab directly and then attach the player script to the prefab. That way, any of the copies of the prefab will automatically contain the player script. If we did want to create a customized version of a prefab object, the warning also lets us know that we could unpack the prefab, and then its components could be modified like any other game object in the scene. But we will attach the player script directly to the player prefab. Now, we can drag the player script up to the top of the component list without seeing the same warning. And when we return to the player object we've placed into our scene, we will see the player script added at the top of the list. Although, we do have to delete the script we added at the bottom now to ensure that this copy doesn't have two player scripts attached. Just to help clarify this, we will delete the copy of the player we have in the scene, and then add the prefab back into the scene to show that it arrives with only one player script at the top of its list. Now, let's begin work on these two new scripts. We will first add both of our new scripts into a custom namespace for this project. As mentioned before, this will also get rid of the harmless gear icon that was being applied to our Game Manager script. Let's start by deleting all of the Unity callbacks that were automatically added to the player script. The player is going to be managed by the Game Manager, so we will define our own managed versions of these methods that will be called by the Game Manager directly. We will now introduce a private reference to the player script in our Game Manager script, and then we will use the Unity callbacks of the Game Manager to call the managed versions that we just defined in the player script. In order to do this, we first need to locate the player script in the awake method of the Game Manager. This can be done by using a static method in the game object class called find, which will locate a game object based on its name in the scene hierarchy. Then we can call getComponent on the game object that is returned in order to get the actual player script component to store into our reference variable. Now that we have the player reference, we can use it to call the managedAwake method that we defined earlier. Then we can follow the same practice to call the other managed methods that were defined in the player script. We will also add the lateUpdate Unity callback because it will be needed for our camera system later. As you can see, not every component that is managed by the game manager will need all of the callbacks, but the game manager will need them in order to make calls to every managed component in the scene. Let's quickly test our setup by printing a line to the console from the managedAwake method in the player script. If we run the application now, we should see that when the game manager awakes in the scene, it will locate the player component and then call its managedAwake method, causing the print statement to be output to the console. We also see our player fall through the ground because its rigid body is being affected by gravity already, but we haven't set up the colliders for our map yet. But if we look at the console output, we can see exactly what we expected. The game manager's awake callback is called automatically by Unity, then it calls the managedAwake method in the player script, leading to the print statement. Let's go ahead and quickly add the colliders to our tile map so that our player no longer falls through the map. We will select the structure tile map and then add a tile map collider 2D component. This will automatically define colliders for each individual tile in the map. Now we're going to add a composite collider 2D component that will merge all of these individual tiles into larger connected colliders. This will not only make the collision detection more efficient, it will also make it much easier for the player's box collider to smoothly move across the tiles. In order to make this work, we need to select Used by Composite for the tile map collider component. We are also going to change the geometry type from outlines to polygons. This will make sure that the player will also trigger a collision if they are completely inside the collider. This will be essential for our climbable layer because we still want the player to trigger the climbable collider even if they fit within the ladder's tile entirely. Now we'll follow the same process for the climbable tile map. We'll add the tile map collider, select the Used by Composite field, add a composite collider, and then set its geometry type to polygons. If we switch back and forth between the structure and the climbable tile maps now, we can see the colliders we've just set up outlined in green. Finally, we need to set these colliders to a body type of static so that they are not affected by forces like gravity. If we run the application right now, we can see the problem. If we look under the rigid body for each tile map, we can find the body type options. If we set both the structure and the climbable tile maps to static, this will fix our problem. Now, when we run the application, the player will land safely on the metal blocks below. We can switch to the scene view and zoom in to see the collision offset in action. Notice that the player's collider is resting on the tile, even though there is still a small space between them. Remember, you can alter this spacing under the Physics 2D settings. The last thing we'll do to set up the physics collisions is to freeze the Z rotation of our player. We do not want the player to be able to rotate in 2 dimensions. If we choose the freeze rotation option, then the player will always remain upright regardless of the collisions it undergoes. But just like when we added the player script, we need to open the player's prefab to make this change in a permanent way. We also need to change our climbable tile map collider to work as a trigger. This means that it will report collisions, but it will not behave like a solid object. We want the player to be able to walk through the ladders, but we also want the collision to be detected. This completes the basic setup of our game manager and player scripts. And we also have the basic collision detection working for our stage. In the next video, we're going to introduce a system that will handle all of our input using Unity's new input system.